Hi guys, today we'll be doing an introduction to generics. So we'll be discussing generics in Java. So a generic class or method is one whose definition uses a placeholder for one or more of the types it works with. The placeholder is really a type parameter. For a generic class, the actual type argument is specified when an object of the generic class is being instantiated. For a generic method, the compiler deduces the actual type argument from the type of data being passed to the method. The Arraylist class. The Arraylist class is generic. The definition of the class uses a type parameter for the type of the elements that will be stored in the collection. Arraylist string specifies a version of the generic Arraylist class that can hold string elements only, or string objects. Arraylist of integer specifies a version of the generic Arraylist class that can hold integer elements only. Instantiation and use of a generic class. So Arraylist of string objects is used as if it was the name of any non-generic class. Example, Arraylist of string objects, myList is equal to new Arraylist of string objects. So we've just declared a string. We've just declared an Arraylist of string objects and we've named it myList. So now we say myList.add the string Java is fun. So we've called the add method of the Arraylist. Then we've created a string variable str is equal to myList.getZero. So if we've created a string named str and we've set it equal to our Arraylist of index 0, which is this right here. So it's going to get that. Writing a generic class. Consider a point as a pair of coordinates x and y, where x and y may be some of any one type. For example, both are the same. So here's an example of a generic point class. So the class is called point, so we've defined class point of generic type t, and t represents a type parameter. So then we've created two variables, private tx and private ty. So you could just think of the t as like an int or a string or like a double. So basically it's saying the same thing as like int x and int y, except that int is substituted for a generic class of type t. So right now type t can be anything. So that's why we're using t. So t represents a type parameter. So the constructor we've just called public and the class name point, and it's taking two parameters, tx and ty. So the same names as the top here. So then in the constructor, the set method is called. So we'll go to the set method. So public void set takes a parameter, tx and ty, so it takes two parameters. And then this keyword is used to instantiate this dot x, so it's going to call the instance variable x that's here, and it's going to set it equal to set it equal to this x right here. So it does the same for y. This dot y equals y. So the same parameters are just being passed here, right? Same parameters as here. Same parameters as here. So it's just saying public void set takes two parameters, tx, ty. This dot x is equal to x, so it's equal to this one. So this dot x is equal to this x here. And then this dot y is equal to this parameter here. That's why it says that right there. So t get x. That should be a space. So t get x and t get y. So it's just a getter method. It just accesses, right? So it's just going to access the x that we've set up here. So it's just going to return x. And then t get y does the same, returns y. Then we've created a toString method, public string toString. Then we're returning, don't have to worry about these, but it's just the actual symbol. So it's just returning x.toString. So we're calling the .toString method because x can be anything. And then y.toString. So then public class test. So this is our main class. So we could just call it main. I'll just say main class. So then here's our command line, public static void main, string array s, could be args. So then we take our point class that we were just looking at, and instead of that generic type t, now we've set it that t, we're substituting that t for string objects here. So it looks like an array list, except you can add parameters. So it just says point of type string objects str is equal to new point of type string objects. And this is actually supposed to be like that. So in an array list, this is just empty, right? Or at least sometimes, like just generally they're empty. So this one here is just taking two strings as we set up here. So it's taking a tx and a ty as parameters, and it's just a class point of type t. So when you instantiate point, you can put any type of object in those angular brackets that you want. It can be an object class that you created, or it can just be any old object like string. But if you have to use a wrapper class, so it could be like integer, double, something like that. So then we've created our point of string objects, and then now we're just printing out str, which is just going to print out this string, these two strings here, Anna and banana. And then we've created another point here of numbers. So we're saying point of type number. So point of type number objects named pi is equal to new point of type number objects, and we've added two parameters. Then we printed out pi. So the point of a generic type class is to be able to easily create whatever you want instead of having to keep writing a new class of strings and then you have to write a new class of numbers. If you're writing a large software project, then that takes a lot of time to do that, and it's repetitive, right? It's unnecessary. So the point of this is just to help make your life easier and to be able to write whatever you want at hand, any kind of objects you want to declare. So that's just the end of that example. So reference types and generic class instantiation. Only reference types can be used to declare or instantiate a generic class. Example: array list of type integer objects named myIntList equals to new array list of type integer objects. So that's correct. So now here's an example of something that would cause an error. So array list of type int, myIntList equals new array list of type int. Sorry, it's a typo there. So that would cause an error. So don't do that. Don't use a primitive type in the Angular brackets. Only use objects. Use like wrapper classes or objects that you create from other classes. So since int is not a reference type, it cannot be used to declare or instantiate a generic class. You must use the corresponding wrapper class to instantiate a generic class with a primitive type argument. So autoboxing. Autoboxing is the automatic conversion of a primitive type to the corresponding wrapper type when it is used in a context where a reference type is required. So autoboxing converts an int to an integer. So this is just an example. Integer int obj equals 351. And here's autoboxing converting a double to a number. So point of type number pi is equal to new point of type number object 3.142.71. So unboxing. Unboxing is the automatic unwrapping of a wrapper type to give the corresponding primitive type when the wrapper type is used in a context that requires a primitive type. Unboxing converts integer to an int. This is supposed to be capital, I think. So it converts the integer object wrapper class to an int primitive type. So int I is set equal to new integer with 34 as a parameter. So autoboxing converts doubles 3.14 and 2.71 to double. So here's an example of that. Point double pi equals new point double and then 3.14 and 2.71. So p.getX returns double from which is unboxed to double. Returns the double wrapper class which is unboxed to double. So double pi is equal to p.getX. Autoboxing, unboxing, and generics. Autoboxing and unboxing are useful with generics. Use wrapper types to instantiate generic classes that will work with primitive types. Example, point of type double object pi equals to new point of type double object 3.14 and 2.71. So just take advantage of autoboxing to pass primitive types to generic methods. So pi.set, and then here's just some longer doubles. Take advantage of unboxing to receive values returned from generic methods. Example, double pi equals pi.getX. So raw types. You can create an instance of a generic class without specifying the actual type of argument. An object created in this manner is said to be of a raw type. Point raw point equals new point, Anna, and then new integer 26. System.out.println raw point. So it's just printing out what we just created. So it prints out Anna and 26. Raw types and casting. The object type is used to unspecified types in raw types. I think it should be just unspecified. The The object type is used to unspecified types in raw types. When using raw types, it is necessary for the programmer to keep track of types used and use casting. Point raw type equals new point. So we're just saying, we're just doing this a new point, we're calling it raw type, we're setting it equal to a new point, and we're now inputting some different parameters. So a string and then another number. So system.out.print raw point, it prints it, and then string name is set equal to a casted to a string of raw point.getX, and int age is set equal to integer casted to raw point.getY, and then it prints out the name and age. Commonly used type parameters. T is used for a generic type. S is used for a generic type with T for multiples. So if you have more than one, then S could be used. E is used to represent generic type of an element in a collection. So you don't have to use those. You can just use whatever you want, but it's just kind of like a standard. So generic objects as parameters. Consider a method that returns the square length of a point object with numeric coordinates. Square length of point 3, 4 is 3 times 3 plus 4 times 4 equals 25. So here just creating a static int method called sqLength is taking a point of type integer named p as a parameter and just setting int x equals to p.getx and int y equals to p.getY. Then it's just returning x times x plus y times y. This method is called as in int I equals sqLength and the new point integer of 3 and 4. sqLength point of type integer p will not work for other numeric types and associated wrappers. For example, it will not work with double. We want a generic version of sqLength that works for all subclasses of the number class. So remember, this is the double wrapper class, since it has a capital. Declaring the method parameter as point of type number object works for point number, but not any point of type t where t is a subclass of number. So static double sqLength of point number named p, that's a method, and then it's just setting double x equals to p.getx, and then dot double value just returns this double value. It does the same for y, and then it returns x times x plus y times y. So it works for a point of type number object p equals the new point of type number 3 and 4. System.out.println sqLength of type p does not work for point integer p equals new point integer 3 and 4. If you print it out, you'll get an error here. Okay, where were we? So wildcard parameters. Generic type checking is very strict. Point of type number references can accept point of type t object, can't accept point of type t object unless t is a number. A point number reference will not accept a point integer object even though integer is a subclass of number. The wildcard type symbol (?) stands for any generic type point of type question mark references will accept a point of type T object for any type T. Use of wildcards. A version using wildcards works for all subclasses of number, but loses benefits of type checking and requires casts. Example: static double SQ length point of type question mark name P. Number n1 equals to number of p dot get x, number n2 equals number of p dot get y, double x equals n1 times double value, double y equals n2 dot double value, and return x times x plus y times y. In our main method, we instantiate a point of type integer objects named p equals the new point of type integer objects, taking a parameter of 3 and 4, and we print out our length, SQ length of type p. Constraining type parameters. Benefits of type checking can be regained by constraining the wildcard type to be a subclass of a specified class. Point of type question mark object P1 is an unconstrained wildcard. Point of type question mark extends number is a constrained wildcard. Excuse me. P2 can accept a point of type T object where T is any type that extends number. Static double SQ length. Point of type question mark extends number P, so number n1 equals p dot get x, number n2 equals p dot get y, double x equals n1 dot double value, so the cast is no longer needed, double y equals to n2 dot double value, return x times x plus y times y. We instantiate it as point of type integer p equals new point of type integer 3, 4 as parameter, and we print out SQ.length of type p. Defining type parameters. The type parameter denoted by a wildcard has no name. If a name for a type parameter is needed or desired, it can be defined in a clause included in the method header. The type definition clause goes just before the return type of the method. Definition. The definition of type, I think this should be defining. Defining a type parameter is useful if you want to use the same type for more than one method parameter, or for a local variable, or for a return type. Using the same type for several method parameters. Static T extends number, void do something, point of type T argument 1 and point of type T argument 2, and it's just whatever you want in the method. Using the name of the generic type for the return type of a method. Static of type T extends number, point T some fun, and then it's saying it takes two parameters, point of type T argument 1 and point of type T argument 2. Constraining type parameters. Class point of type T extends number. T is constrained to a subclass of number, so like double, float, or whatever. Int. Private T of y, private T of x, and then ty. So it's just declaring two variables, and then this is a constructor. It's taking two parameters, tx and ty. It's setting this dot x equals to x, so setting the instance data equal to the parameter. Does the same for y. This dot y equals y. Then we're saying double x1 equals x dot double value. double y1 equals y dot double value, return x1 times x1 plus y1 times y1. Public t get x, so just returns x, does the same for y. Public string to string, return x dot to string plus y times dot to string. Type parameters can be constrained in generic classes. So point of type integer p equals new point of type integer 3 and 4. So that's correct. System.out.println p dot sq dot get length. Point of type string object q equals to new point of type string object Anna and banana. This is an error because string is not a subclass of number. Okay, upper and lower bounds. The constraint t extends number. Establish number as an upper bound for type t. The constraint says t may be any subclass of number. A similar constraint t super integer establishes integer as a lower bound for t. The constraint says t may be any superclass of integers, so anything above it like number. But for t extends number, it can be any subclass such as like the wrapper double or integer. So if you don't know the hierarchy, just have a look at the hierarchy of number. Defining multiple type parameters. A generic class or method can have multiple type parameters. Example, class, my class takes two parameters of type S and T, of generic type S and generic type T. Multiple type parameters can be constrained. So you can say S extends number and then T extends date. A class with multiple type parameters, here's just the same kind of class, just different. So private T first, private S second. So this you could just pretend like this is like an int, this is like a double, or this is like a string and this is like a double. And then this is the constructor. So public pair takes two parameters tx and sy, and we've set first equal to x. So first is equal to x, and then second is equal to y. So instead of using this keyword, just done it differently here, because some examples you may see like that. So now this is just accessor methods. It gets first, and then gets second, returns second. Remember the type it returns, it has to be the same as whatever it was declared. So t is declared. First is declared of type t. So if you're returning first, you just return the same type that you defined. So use of multiple type parameters. So import java.util.date public class test. So this is just main class. Public static void main command line. Pair of type string and date p equals a new pair of type string and date, and it takes Joe as a parameter and then a new date as another parameter. And then just prints out get first using the p object to access the get first method, and the same for the get second method. Generics and interfaces. Interfaces like classes can be generic. An example of a generic interface in the class libraries is, for example, public interface comparable of type T. So we've gone over the comparable interface. So int compare to is the only method that it contains. and it takes a parameter of t, type t, just called obj. This interface is implemented by classes that need to compare their objects according to some natural order. So public interface comparable of type t in compare to t object, same thing. The compare to method returns a negative integer if the calling object is less than the other object, returns 0 if the calling object is equal to the other object, and returns a positive integer if the calling object is greater than the other object. So implementing the comparable interface. I think we've done a better example than this, but we'll just go over this now. So public class employee implements comparable of type employee object. So instead of t, we're using employee. So private int rank, private string name, so it declares two variables. There's no constructor. Here's a method, public int compare to. It takes a employee object of type e as a parameter. It returns this dot rank minus e dot rank. Public employee string n and in r. Rank is equal to r, name is equal to n. Just a public string toString returns name plus rank. Comparing employee objects. So employee big shot equals new employee Maxwell manager as a string, and then the int is 10. And then employee little shot equals new employee Walter worker, and 1 as a integer. Shows in rank order if big shot dot compared to little shot is greater than 0. System dot out big shot, system dot out little shot, else system dot out little shot, and system dot out big shot. So type parameters implementing interfaces. A type parameter can be constrained to a type implementing an interface. So public static t extends comparable of type t. T greatest takes a parameter of type t arg1 and type t arg2. If arg1 dot compare to arg2 is greater than 0, return arg1, else return arg2 or arg2. So type parameters implementing interfaces. So here's a command line, public static void main, and we just instantiated the same things again. And we've created a type employee named great, set it equal to greatest, the method greatest, and taken big shot and little shot as a parameter. And we've system.out.println great. So that concludes our discussion of generic types. So I hope that helps, and I'll see you later. Take care.